So in this lesson, we'll go over the last way of combining two functions. So previously we talked about adding functions, subtracting functions, multiplying functions, and dividing functions. So in this lesson, we're going to create a composite function, and we do so by having a composition of two functions. And that sounds really fancy, but what you're really doing is nesting one function into another function, which is actually something you probably have done in grade 11. And when I think of a composition of functions or a nesting of one function into another function, I think of this pretty popular movie. And unfortunately, when I tell the students this movie, very few students have watched this movie. So when I think of a composition of two functions, I think of the movie called Inception. It's a great movie. If you haven't watched it, maybe you have a chance to watch it during quarantine. But it's based, I don't want to ruin the movie, but it's a dream within a dream, or even think of it more complicated in terms of a dream within a dream within a dream. But anyways, if that is too complicated, let's just talk about composite functions. So the notation is something you've seen in grade 11. So f of g of x. So g of x is nested inside the function of f. Okay, and we have another notation that is saying the same thing as what we have here, which is f of g of x, which is right here, f circle g of x. So f circle g of x means exactly the same thing. F circle g of x is f of g of x. So I personally prefer f of g of x because students from grade 11s have seen this many times. But in the homework or in the textbook, you might see this circle notation, this f circle g of x. So be comfortable with either or. So let's start off with something pretty straightforward. For example, 1, I give you f of x, I give you g of x, and I ask you to find g of f of x and f of g of x. So let's find g of f of x first. So I take my function g, and every time I see x, I replace it with f of x, which in this case is 5x minus 4. And then I just expand and simplify, so perfect square trinomial. Okay, there's g of f of x. Oops, it's g of x is x squared plus 3. Okay, there we go. Okay, so let's now find f of g of x. F of g of x, so this time I'm going to take f of x, and every time I see x, I replace it with g of x because I'm nesting g in f. So instead of 5x minus 4, I'm going to write 5 times x squared plus 3 minus 4, right? So it used to be 5x minus 4, but now it's 5 times g of x minus 4. Expand, simplify, 15 minus 4 is 11. You can take your time, you can do 2 steps, but I'm going to save some time. Okay, so example 2. Oh, sorry, before I go to example 2, I just want to mention the reason why I gave this example was for 2 reasons. The first one being, I just want you to practice finding a composite function. So whether it's g of f or f of g, you should really have no problem. It's just really an application of function notation. The second reason I gave this question was because I want you to understand that f of g and g of f are entirely different. Now they may be the same, but more likely than not, they will not be the same. Okay, so please do not say f of g and g of f, they look similar enough and they're the same. They're very different. The order matters. Nesting f into g and g into f is very different in most cases. Okay, so now we're going to do another special situation here. So I give you f and g again, and I ask you to find f of g of x, and I ask you to find g of f of x one more time. Now before you find f of g and g of f, I want you to take a look at f and take a look at g, and hopefully you see something special. There's a special relationship between the two functions. I don't want to spoil it, but when you do the math, when you find f of g and g of f, hopefully the relationship between f and g becomes apparent. So let's find f of g first. So same strategy as before. I see f, and every time I see x, every time I see x, I replace it with g. And if you simplify that, it becomes x. Interesting. So hopefully you already see the relationship, but if you don't, I'll write it over here. G of f of x. So instead of saying x cubed minus 2, I'm going to write the cube root of x plus 2 cubed minus 2. And lo and behold, if you simplify g of f of x, you also get x. So hopefully by now you see the relationship between f and g. But if you don't, what is this really saying? When f of g of x and g of f of x, they both equal to x. Now it seems to contradict what I said earlier, because I said f of g and g of f are usually different. But not only are they the same, they're both equal to x. So this actually implies that the special relationship between f and g is the fact that they are inverses of one another. F and g are inverses of one another. And if you stared at it long enough, it would make perfect sense that they are inverses. Because look at g, for example. I have an input. What do? I have x and I cube it and then I subtract by 2. Now how do I reverse these steps? Okay, if I cube and then subtract by 2, how do I undo the subtraction by 2? You add by 2. And then how do you undo the cubing? You cube root. So if you look, f absolutely will undo the effects of g. And if you start with f, g will undo the effects of f. So that's why it makes sense that you're back to x. Okay? So if f of g of x is equal to x, or g of f of x is equal to x, it's telling you a special relationship that exists between f and g. F and g are inverses of one another. Okay? So I just want to write this relationship. It makes perfect sense, because if you're nesting the inverse into the original function, okay, so the inverse of f is nested inside of f. So imagine this function here undoes the effect of f. Okay, so it makes perfect sense that this is equal to x. Okay, so let's look at example 3 here. Given h of x, we have this. Determine two functions f of x and g of x, which when composed generate h of x. So there are a lot of ways to do this question, but because you do see a pattern here, the binomial x plus 1 occurs 2 times, so there is probably a very straightforward answer to this question that pops into your mind right away. So let's see, f of x and g of x. What is one way of composing f and g to get h? I think the most common way is if you let f of x equal x plus 1 and g of x to be x squared plus 2x minus 3. Because if you nest f into g, you're going to get this x plus 1 replacing x, right? So h of x equals, let's see, what did I say? F into g, right? So it's going to be g of f of x. And get g of f of x. So you want to nest f into g, not the other way around, because the other way around will not get you h of x. Okay, so there's another silly way of doing it. I would not like this as an answer on the test, but there's nothing wrong with it. So one way of, or another way of doing it is if f of x equals x and g of x is equal to x plus 1 squared plus 2 times x plus 1 minus 3. So if you think about it, let's do f into g. Okay, if you nest f inside of the function g, you replace x with x, which means nothing has changed. So if you replace x with x, you're still going to get g of x, and guess what? G of x I've copied to be h of x. So f and g, so it's g of f of x. And in fact, you could go the other way around. You can replace x with this, g of x, and you'll still get h of x, because I made g of x to be equal to h of x. So in fact, you could argue, if you wrote f of x to be x and g of x to be this, you could have wrote g of f of x to be h of x, or h of x can also be f of g of x. Okay? So there are more ways to do it, but I'll let you play around with f of x and g of x to try to create h of x. Okay. So for example 4, we're given f of x, we're given g of x. Find the values of x where f of g of x is equal to g of f of x. So this question, nothing really special about it. I put this question just to practice your algebraic skills. So f of g, so that's f of g, right? Every time I see x, I replace it with 3x minus 5. G of f would be 3. Okay. And there really is no shortcut here. Expand, 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 simplify, and then set equal to 0, and cross your fingers and hope the quadratic is factorable. If it's not factorable, use the quadratic formula. So let's see. Just don't make a careless mistake here, because that will cascade and you won't get the correct answer. So I'm going to simplify. I'm going to try to save myself a few steps, but you can take your time. So 60x minus 69x, 50, 15 is 65, 64. So this is 12x squared, 69, this is minus 60, and then 72. Just making sure everything looks good. Divide everything by 12. Ooh, what do you know? It is factorable. Simple trinomial, what multiplies 6 and adds to the negative 5. Negative 2, negative 3. Beautiful. So x equals 2 or x equals 3 from the zero product property. And of course you can check. You can find f of g of 2 and g of f of 2. And f of g of 3 and g of f of 3. Okay, next question here. I have f, I have g. I want you to state the domain of f of g of x and g of f of x. So the reason I put this question is because we talked about the domain in, the domain of functions which are created by adding, subtracting, multiplying, dividing. So for adding, subtracting, and multiplying, we talked about the common elements, or where the domains of the two functions intersect. Now division is a little special because it's not only where the domains intersect, but also where the function you're dividing by is equal to 0. Now what about combining functions through a composition of the two functions? Well, if it's a composition of the two functions, f and g, then the way you find a domain is a little trickier, to be honest with you. So we're going to take a look at this example, and then we'll talk about the strategy. So f of x is x squared minus 1, and g of x is equal to 1 over x. Let's do f of g of x first. So f of g of x, f of g, so it's 1 over x all squared minus 1. So it's 1 over x squared minus 1. And we can simplify this, but since we're only asked for the domain, I'll just focus on that. So how do you find the domain of f of g of x? So first of all, you have to look at what the domain of g of x is. Because if g of x is undefined, then then those values of x cannot be part of the domain of f of g of x. So first ask yourself, what must g of x, what does x need to be in order for g of x to be defined? And in this case, x, as long as x is not 0, g of x is defined. Okay, so here's the tricky part. You have to ask yourself, what values of the range of g of x can be a part of the domain of f of x? Okay, because the values that 1 over x spit out, it has to be okay with f of x. It has to be making f of x to be defined. So luckily, the domain of f of x is all real numbers in this case. The domain of f of x is all real numbers, so no matter what 1 over x is equal to, it will still be defined. F of g of x will still be defined because the domain of f of x is all real numbers. So in this case, the domain of f of g of x is any value of x as long as it's not 0. Okay? So let's go back. It makes sense that this is the case because if x is 0, 1 over x is undefined, or g of x is undefined. Okay? So if x is 0, g of x is undefined. Now, if x was not 0, g of x is defined, and all those values that g of x spit out, the output values of g of x, will still make f of x defined. So all the values of the range of g of x are part of the domain of f of x. So that's why we only have one restriction here. But if you look at the next example, that's not the case. So I'm going to g of f of x. So g of f, so it's going to be 1 over x squared minus 1. Okay, so let's start off with f of x again. So f of x, the domain of f of x is all real numbers. Okay, the domain of f of x is all real numbers. Beautiful. So there's not going to be restrictions on if you just look at f of x, but be careful. We are nesting f of x inside g of x. So you have to be careful with the values that f of x spit out. F of x is spitting out values that may create a problem, because what did g of x not let, like what was not part of the domain of g of x? If you look at g of x, it's 1 over x. You can't let x equal to be 0. So if that's the case, f of x can't be 0. Okay, that's the value in the range of f of x that you can't let occur, because that is not part of the domain of g of x. Okay, so don't let f of x equal 0. So that's why this one's a little trickier when you work with composite functions, because you have to investigate the range of a function, not only just the domain. So the domain of g of f is, so we can't let f of x equal to 0, which means x cannot be plus or minus 1. Anything else, no problem. X cannot be plus minus 1. So whenever someone asks me to find the domain of a composite function, my strategy is pretty much the same. So the first thing I do is I study the domain of the inner function, which in this case is g of x. And then I also study the range of the inner function, because the range of the inner function has to be a part of the domain of the outer function in order for the composite function to be defined. So that's what makes composite functions a little trickier when you're trying to find the domain, because you have to study the domain and the range, whereas before you just study the domain, and at most you have to figure out where a function is equal to 0. So that's my strategy for finding the domain of a composite function. Okay, so last question here. A cylindrical container has 500 cubic centimeters of water and is being filled at a constant rate of 100 cubic centimeters per second. The radius of the container is 50 centimeters. When does the height of the water in the container reach 1 meter? So I'm first going to start off by saying the volume as a function of time, because they tell me the initial volume and it is filled at a constant rate. Okay. And in this question, we actually need to know the volume of a cylinder. Okay. So since they're asking me what is or when does the height of the water in the container reach 1 meter, I need to rearrange this formula. I want to isolate the height and express it as a function of volume. Now, since the radius is fixed to be 50 centimeters, then V is equal to 2500 pi. H of V is equal to V over 2500 pi. Now, I don't want to express height as a function of volume, because based on the question, when, I want to express height as a function of time. So instead of H of V, I prefer H of T. So luckily, I have a relationship between volume and time, so that will allow me to express height as a function of time, right? That's the power of nesting this function inside H of V. Okay, so then I can express height as a function of time. So therefore, the height as a function of time is 100t plus 500 over 2500 pi. And we're gonna let H of T, the height of the water in the container, to be 100. Be careful, it's 100 because we're working with centimeters and this is a meter. So 1 meter is 100 centimeters. And we solve for T, solve for the time. So you can crunch it out. But basically, it's a grade 9 linear equation, so about 7,849. So therefore, it will take approximately 7,849 seconds. Okay, so this is the last way of combining two functions.